this video, I'm going to show you how to find these two integrals. And the method that we're going to need to use to find these two integrals is completing the square, and specifically completing the square in the denominator. Now, another thing about these two integrals is it will produce an inverse trig function. So let me walk through what those two will look like. So one of them is if you have the integral of du divided by the square root of a squared minus u squared, where a is a constant. Let me write that out here. A is a constant. This will give you arcsine of u over a plus c. Now, arcsine could also be rewritten like that. That would mean the same thing as arcsine. So that is one that we're going to use. And then the other one we're going to use is if it looks like this, du divided by a squared plus u squared, then that's going to produce 1 over a arctangent of u over a plus c. So now let's see how we would put this to use and find these two integrals using completing the square and an integral that would produce an inverse trig function. Now I can already tell that once I complete the square and show you how to do that, I do know that it is going to require the use of the second one. And the reason I know that is because it doesn't have a square root in the denominator. So let's go ahead and complete the square, and I'll show you how we can make it look like that one that I just circled. So to complete the square, I would write x squared minus 10x, and then I like to leave a blank. That's where I'm going to complete the square. Then I'm going to move the 34 over and give another blank, and I'll show you what I'll use that for in just a minute. So what I want to do now is I want to complete the square for this trinomial. To complete the square, I take the coefficient of x and I divide it by 2. Then I square that number, and this will always be the case. You'll always divide it by 2 and square it. So that would give us 25. Now, I can't just go in and add 25. I need to undo what we just did. So I will need to go back and subtract 25. By completing the square, I've turned that trinomial into something called a perfect square trinomial. And a perfect square trinomial can always be then factored as a binomial squared. And the way we factor x squared minus 10x plus 25 is x minus 5 squared. And then I would have 34 and negative 25, which would give us plus 9. So this allows us to rewrite this integral as dx all divided by x minus 5 squared plus 9. And I haven't changed the problem at all. So if you were to multiply x minus 5 times x minus 5 and then add 9 to it, you would get x squared minus 10x plus 34. But what this does allow us to do now is it does allow us to write it using u-substitution in the form that you see in the lower right. And I can write it like that if I set u equal to x minus 5. And then the derivative of u with respect to x would be 1, or du is equal to dx. And now by thinking about a squared being 9, or a being 3, I can write this now in the form as we see in the lower right. So it would be the integral of, since dx is the same as du, I can replace dx with du. And then the denominator, I can keep it as x minus 5 squared plus 9, or I can write this as, better yet, u squared plus, and 9 I'll go ahead and write as 3 squared, so we can see that the a value is 3. Now I know I wrote it in a different order as I have down below, but whether I write it as u squared plus 3 squared or 3 squared plus u squared, I would have the same thing. Now I can integrate this. And as you can see on the right, that would give us 1 divided by a, which is 3, times arctangent of u divided by our a value of 3 plus c. For our final step, all we need to do is replace u with the quantity x minus 5. And that is how to integrate using completing the square of this integral. Let's look at another one that's a bit different. In this integral, I see that I have a square root in the denominator. So you know what? This one is going to produce an arcsine function, but it will require us to complete the square. So let's do that off to the side. I want to complete the square with what is underneath the radical, so the radicand. And what I'm going to do is I'm going to flip those terms around and write it as negative x squared plus 4x. Now, in order to complete the square, I do need the coefficient of x squared to be a positive 1. So I'm going to factor out the negative 1 and then set it up to complete the square. Once again, I leave a space there to complete the square. Now, again, if I add a number, I have to undo what I just did, so I'll put another space out there. To complete the square, you're going to take the coefficient of x and divide by 2. And then you square that number. So here we get a positive 4. Now, a common mistake that people make is they see that we wrote plus 4, and so then outside the parentheses, they undo it by subtracting 4. But we need to be careful because with this negative 1 out in front, we've actually added a negative 4. So to undo adding a negative 4, I will need to add 4 on the outside. Completing the square this way allows us to write this perfect square trinomial as x plus 2 squared. And then we have the plus 4. Now, to make it look a little bit more like the form that we're having in the lower right, which is the square root of a squared minus u squared, where a is a constant, I'm going to flip-flop this around and write it as 4 minus the quantity x plus 2 squared. Now I can see that if a squared is 4, a must be 2, and if u is x plus 2, then the derivative of u with respect to x would be 1, or du is equal to dx. This allows us to rewrite this integral. So this would be the integral of, first I'll show you, once we completed the square, this radical can be rewritten as 4 minus x minus 2 squared. And again, I have not changed the problem at all. This would be identical. So if I multiplied x minus 2 times x minus 2 and then did 4 minus that quantity, it would return to the 4x minus x squared that I have right there as the radicand. But now I can write this as du divided by the square root of 2 squared minus u squared, thus making it look like what I circled down there to the right. Now it's time to integrate. This would give us arcsine of u over our a value of 2 plus c, and then my last step, all I need to do is substitute the x plus 2 back in for the u. So my final answer is arcsine of x plus 2 over 2 plus c. And there we have it. I hope by going through these two problems, you now feel a little bit more confident on how to complete the square to produce an arc trig function after you find the integral.